come and study with Tanzania Institute of Education.
Al-Khwarizmi is a 9th century mathematician from Baghdad who is credited as being the father of algebra. The word algebra is a Latin translation of the Arabic word al-jabr, which means reunion of broken parts, and comes from the title of an important work by Al-Khwarizmi. Algebra can be seen as the language of mathematics. And like any new language, there are rules and definitions which you need to learn and practice often. What is a variable? A variable is a symbol that represents an unknown value. We often use letters for variables, of which X is the letter most commonly used to represent a variable. The reason for this takes us back to Al-Khwarizmi. In his manuscript, variables were called things. The Arabic word for thing is shay. When al-jabr was later translated into Spanish, the word shay was written as X-E-I, which people then started to write as the letter X to make their lives easier. And this has stuck. Another word we encounter often in algebra is constant. This is exactly what it says, a value that is constant and does not change. Numbers which are given in a mathematical statement are constants. In this statement, for example, X is a variable and 3 is a constant. What is a coefficient? A coefficient is a number used to multiply a variable. The coefficient also includes the positive or negative sign. Here, minus 2x means negative 2 times x, so the coefficient of x is negative 2. If the coefficient of a variable is 1, we usually don't write it down. What is the exponent or power of a variable? The power of a variable tells you how many times the variable is multiplied. For example, x to the power of 4 is x times x times x times x. What is a term? In algebra, a term can be either a single number or a variable, or numbers and variables multiplied together. Also, if two separate terms are placed above and below a division line, they become one term. Like terms have the same variables and they are raised to the same power. Their coefficients can be different. This means that they are of the same type, so we can add or subtract them. For example, 2x squared minus 10x squared equals negative 8x squared. Unlike terms have different variables. For example, 8a and negative 10x squared. We can't add these together because they are not of the same type. Look at the following terms, 6 and minus 2x, which is the same as minus 2 times x. If we add the two terms together, we get the following expression, 6 minus 2x. An algebraic expression is composed of terms separated by plus or minus signs. Note that adding a negative term is the same as subtracting a term. So we could actually say that an algebraic expression consists of terms separated by plus signs, because the sign of the coefficient is part of the coefficient itself. Algebraic expressions can represent different quantities. A variable in an expression stands for an unknown quantity. For example, this shape has two sides that have an unknown length x, as well as one side of 10 meters and another of 16 meters. We don't know what the shape really looks like because x is an unknown length. This diagram is just to help us. Let's write a mathematical expression for the area using the information we have. The shape is made of two rectangles. The sides of the first rectangle are 10 meters and x. The sides of the second rectangle are x and 16 minus x. The total area is equal to the area of rectangle 1 plus the area of rectangle 2. The area of the first rectangle is equal to 10 times x, which we write as 10x. The area of the second rectangle is x times 16 minus x. Multiply x by the 16 to get 16x. Then multiply x by the minus x to get minus x squared. Remember, to multiply a term in brackets, we multiply each term of the expression in brackets. Now we can add the two expressions together. 10x plus 16x minus x squared. 10x and 16x are like terms, so we add them together to get 26x. This gives negative x squared plus 26x. Now we move on to a specific section of algebra called polynomials. Polynomials are a special kind of algebraic expression. The word polynomial comes from poly, meaning many, and nomial, meaning term, so the word means many terms. But not all algebraic expressions with many terms are polynomials. These are the rules that make an algebraic expression a polynomial. First, the exponent of the variable must be a whole number, such as 0, 1, 2, 3, and so on. So, if an algebraic fraction has a variable in the denominator, it is not a polynomial, because this means that the variable is raised to a negative power. For example, 1 divided by x equals x to the power of negative 1. And the variables cannot be under a root sign. This would mean there is a fractional exponent. For example, some more obvious rules are that the coefficients must all be real numbers and there are a finite number of terms in a polynomial. Therefore, these expressions are not polynomials. 10xy to the power of negative 2 is not a polynomial because exponents may not be negative. 4 divided by x plus 1 is not a polynomial because a polynomial may not have a variable in the denominator. The term x plus 1 would be raised to negative 1 as it is in the denominator. The square root of x is not a polynomial because this would be raised to the power of 1/2. Sometimes it may look like an expression is not a polynomial, but if you check, you will see that it is. For example, this fraction 10xy to the power of 10, all divided by 3, is a polynomial because the denominator does not contain a variable. The polynomial 4x to the power of 3 plus x plus 3 to the power of 1/2 also obeys the rules and is a polynomial. The constant 3 is raised to 1/2, but the variables are raised to positive integer powers. The square root of 2 times x plus 1 is a polynomial because, although there is a square root, the square root of 2 is a coefficient and it is a real number. You might be surprised that any number, for example 2, is a polynomial. The number 2 is equal to 2 times x to the power of 0, so it obeys the rules. It's called a constant polynomial. What about a polynomial where all the coefficients are 0? In this case, it doesn't matter what the value of x is, the polynomial will equal 0. This is called the zero polynomial. Polynomials can have any finite number of terms. We have special names for those with 1, 2, and 3 terms. Polynomials that only have one term are called monomials, mono meaning one. Think monocycle. Polynomials that have only 2 terms are called binomials, bi meaning 2. Think bicycle. Polynomials that have only 3 terms are called trinomials, tri meaning 3. Think tricycle. We call the highest power of the variable the degree of the polynomial. For example, in this polynomial, the term with the highest power of x is 3x squared. The exponent of x in this term is 2. Therefore, the degree of this polynomial is 2. Remember that x is actually x to the power of 1 and that the constant term can be seen as multiplied by x to the power of 0. The degree of a polynomial changes the shape of the graph of the polynomial. Look at these shapes, which can be used to represent polynomials of degree 1, 2, and 3. A polynomial of degree 1 is called a linear polynomial. The word linear means a straight line. A polynomial of degree 2 is called a quadratic polynomial. The word quadratic comes from the word for square because the variable is squared. A polynomial of degree 3 is called a cubic polynomial. The variable in this case is cubed. These are the polynomials that we are going to work with. Let's write an algebraic expression for the area of this shape. The length of each side is represented by a linear binomial. This is because they each consist of two terms and the highest degree of the variable is 1. So to find the area of the rectangle, we multiply the binomials together. You have probably learnt the FOIL rule for multiplying binomials before. It shows that we can begin by multiplying the first two terms, then the outer terms, then the two inner terms, then the two last terms. Then add the results. So in our example, we have 2x times 4x is 8x squared. 2x times 1 equals 2x, minus 3 times 4x is minus 12x, and minus 3 times 1 equals minus 3. Now we add the like terms. 2x and minus 12x to get 10x. The final result is 8x squared minus 10x minus 3. Polynomials are in standard form if they are arranged in a certain way. The terms are put in order so that the exponents of the variable are in order from largest to smallest with the constant last. It is a good idea to rearrange a polynomial in this way before you do anything further with it, so you know what you are dealing with, which will help when simplifying and factorizing. Take this polynomial, for example. It is not in standard form. Simply reorganize the order of the terms so that the exponents are from largest to smallest. Remember that the positive or negative sign of a coefficient is part of the coefficient and they must always move with the coefficient. The polynomial is now in standard form. This is great because now the leading coefficient, the coefficient of the first term, tells us the degree of the polynomial. Let's work through an example. In this case, the polynomial is called p of x. In the polynomial p of x, the term with the highest power of x is 3x to the power of 7. The exponent of x in this term is 7. Therefore, the degree of this polynomial is 7. So to write it in the standard form, the first term will be 3 times x to the power of 7. The constant comes last. When we add or subtract polynomials, we are simply making one polynomial out of two or more polynomials. For example, let's subtract these two polynomials. We're starting with this polynomial and subtracting this one. Step 1. The whole of the second polynomial is subtracted from the first. So each term in brackets must be multiplied by the negative sign. So we multiply each of the terms by -1 and take out the brackets. We are left with a long polynomial. Step 2. Put the like terms together to make the last step more clear. Remember that the sign of the coefficient goes with the coefficient. Step 3. Add or subtract the like terms. We now have a single cubic polynomial of 4 terms. Here's another example. In this case, the first expression is written in its factorized form. We'll have to multiply it out so that we can add and subtract the terms. Step 1. Multiply the terms of the first polynomial. Step 2. Take out the brackets. We don't need to change any signs since we are adding. Step 3. Group the like terms. Put the terms with the highest powers first, so this means we write x to the power of 4 first. Step 4. Add or subtract the like terms.